Good evening. Welcome back to our channel, Afri Edu, where we'll be solving mathematics problems. In this paper, we are going to tackle a grade 11 paper. This is a grade 11 paper. So we are going to tackle the questions on Euclidean geometry. In this question, in the diagram below, O is the center of the circle here, and point T lies on the chord RS. Prove the theorem which states that if OT is perpendicular, as shown here, if OT is perpendicular to RTS, then RT is equal to TS. So whenever we are doing proofs and theorem, the theorem that you have to know that the first step that you have to do is to construct. So in this question, what is the requirement? In this question, what is required? If we check what is required, you are given a line drawn from center perpendicular to a chord. So you are required to prove that RT is equal to TS. So to do the proof, always we start by construction. So we are going to start by construction. We are going to start by construction. What is it that we are going to construct? We are going to construct radius OS there. Then another radius OR. So it means step 1, we are going to construct two radii. That is radii OR and OS. So in that particular, we can now prove that OR is equal to OS. What is the reason? They are both radii. Then we can prove now that T1 is equal to T2, which are both equal to 90 degrees. Considering that this is a straight line, you are given that here is 90 degrees, and 90 plus this must give us 190. Here, those are angles on a straight line. Then, if you check, we can say OT is equal to OT. We are considering this triangle, whatever we were doing, and this triangle, it's a common side. So we have proven that this side, and this angle are equal, are all equal to each other. So we can conclude that it's triangle ORT. We can conclude that triangle ORT is congruent to triangle or is congruent to triangle or ST. Why are we saying they are congruent? By congruent, we are saying they are equal to each other because we have proven that the right angle, the hypotenuse, and another side are equal. That is the right angle where we proved we have 90, we concluded that the hypotenuse, which is the side opposite the right angle, side opposite the right angle are equal. Then the third side are equal. So if these two triangles are are congruent, not similar. Congruent, it means they are actually equal. So since these two triangles are congruent, we can therefore conclude that RT must be equal to TS. Why? Because the two triangles are congruent. Therefore, it means the corresponding sides must be equal. So we are now on question 9.2. So in this question, we are given in the diagram O is the center. You are given the center. You are given O is the center of the circle ABD. F is a point on the chord AB there such that DOF is perpendicular to AB. AB there you are told that AB is equal to DF, which is equal to 8 centimeters, and OF is equal to X. Then the question is saying determine the length of the radius of the circle. We are required to determine the length of the radius of the circle. So according to what you are having here, the theorems that we are going to use, our circle, we are supposed to know that we have got center theorems, then we have got tangent theorems, then cyclic quad theorems. So according to what we are having here, we only learned that we have center. We are not having a tangent on the circle. We are not having 4 points on the circumference or a cyclic quad. So we are restricted to use of the center theorems. And on center theorems, we are having angle at center is twice angle at circumference, which is not shown in this diagram because we don't have an angle at the circumference. We also have angle in a semicircle, which is again not here because that for us to apply angle in a semicircle, we must be having a diameter. Then we are having line drawn from center perpendicular to a chord. We are seeing we have a line from center perpendicular to the chord AB. Then we are having another theorem, which is line from center bisecting a chord. In this case, we are not seeing any line from center which is bisecting a chord. So it means from this, we are only going to use one theorem, which talks about line from center perpendicular to a chord. That's the main theorem, line from center perpendicular to chord, because that's what we are seeing. So to answer this question, now, what are we going to do? We are given this line from center, which is perpendicular to this. So we can conclude that AF So from here we can conclude that AF must be equal to FB. The reason is line from center perpendicular to a chord. Then it means here is equal to that. Then you are told that AB, here it is. We are told that AB is 8 centimeters. So we can therefore conclude that AF is 4 centimeters and this other part is also 4 centimeters. So our FB, it means this must be equal to 4 centimeters. This must be equal to 4 centimeters. Then, if we come, the question wants you to calculate the radius. You are also told that FD, this is F up to D. You are also told that it's 8 centimeters again. And we know the question wants you to calculate the radius. We know our radius OD is equal to OB. Any line from center to the circumference is radius. OD is equal to OB. The reason they are both radii. They are both radii. So, from what we have, we can calculate OD. Here, we can calculate OD. How do we calculate OD? OD must be equal to FD, which is that full length. FD, here, which is that full length, which we are told it's 8. Minus the small part OF, which we are told that it's X. Then, let's calculate our OB. To calculate our OB, we can use Pythagoras theorem in the right-angled triangle FBO. So OB squared, the hypotenuse squared, the side opposite the right angle, OB squared, must be equal to the sum of the two sides, each squared. So must be equal to 4 squared plus X squared. That is after we apply Pythagoras. That is after applying Pythagoras theorem. So, if we simplify, it means OB squared must be equal to 16 plus X squared when we simplify. But Tina, we want OB, so if we square both sides, take note, we are not going to take the negative root because we are talking of distance. So it will mean that the OB must be equal to the square root of 16 plus X squared. It is important to take note that we cannot distribute the root sign between these two terms to make 16 root 16 plus root x squared. We cannot do that. We have to just put the two terms under one root sign. Then, in earlier onward, side OD is equal to OB. So it means we have OD there, we have OB there. So we need to equate the two. Since we said they are both there, they are equal. So it will mean that 8 minus x must be equal to the square root of 16 plus x squared. Then to take rid of the square root, we now have equation with the said. It means we have to come and square both sides. Come square both sides. When you square here, it's going to be this 8 squared is 64. Then the 8 times a negative x times the 2, it gives us a negative 16x. Then plus this squared, x squared, must be equal to the 2, that power and this root sign will go. So we'll be left with 16 plus x squared. If we take note here, it is very important to take note that here the expansion can be done step by step. It's going to be 8 minus x multiplied by 8 minus x. So this 8 times this 8 is going to give us this 8 multiplied by this 8 is going to give us a 64. This 8 multiplied by this x is going to give us a negative 8x. Then this x and this 8 is going to be a negative x. Then this negative x and this negative x here is going to be a positive x squared. So we have 64 minus 8x minus x is minus 16x, then plus x squared there. Then from there, it means we can simplify this, take this x to this side. So it means this x, if we combine with this x, it's gone. Then here we take the negative 16x. If we take this 64 to this side, it's going to be 16 minus 64. We are going to get a negative 48. Then dividing both sides by a negative 16. It means the x gonna be equal to 3 units. The x gonna be equal to 3 centimeters. But the question wants the radius. So the radius, once you get the value of x, you can come and substitute it here where we are having OD. So therefore, the radius not writing properly, the radius must be equal to, remember we said OD is radius, so it's going to be 8 minus the value there, which is 3, which gives you 5 centimeters. But alternatively, you can take the value of x which you obtain here, come and substitute in the formula for OB. So it means the radius, if you use OB, will be equal to the square root of 16 plus x. The x is what? It's 3. 3 squared. The square root of that is going to give us a 5. So it's going to be 5 centimeters. We are now on question 10, where we are given M is the center of the circle, having equal chords SV and QR. RP and QP are tangents to the circle at R and Q respectively, such that this angle is 70 degrees. So if we are to check here, as according to the classification of our theorems, they spoke about the center. They spoke about the center. So it means we expect center theorems. They spoke about the tangents. We can be having theorems on the tangents that will help us solve the equation. Then they also spoke, we have 4 points on the circumference. So we can expect to also talk about the quads. So from these theorems, if we go to the specific answering of the question, the first size is calculate the size of R2. If we check, here is our R2. So our R2, if we check, we are told RP. Here is a tangent, and we are told Q, that is a tangent. And we now have two tangents from the same point. So we can now conclude that QP is equal to RP. So here, to answer that question 10.1, we can just go and say QP is equal to RP. What is the reason for that? These are tangents from same point. Tangents from same point. So if we are to consider that these two are equal, and we now have this as a triangle because we have called QR, so we can consider triangle PQR. It therefore means that this angle R2 and this angle, it will therefore means the angle R2 and the angle Q2 are equal, because these sides are also equal. The reason for that, those are angles opposite equal sides. Those are angles opposite equal sides in this particular triangle. Therefore, from there, we can now say R2 in that same triangle plus Q2 plus angle P must be equal to 180 degrees. These are sum of angles in a triangle, sum of angles in a triangle. But we concluded that R2 and Q2 are the same, are equal. So this R2, where there's Q2, we come and substitute R2. So R2 plus R2, it becomes 2R2 must be equal to 180 degrees minus P. The size of P is 70 degrees. Then it means the R2 will be equal to this divided by 2. That is dividing by 2 both sides here. So we are going to get our R2 being equal to 55 degrees. After getting 180 minus 70, we get 110. 110 divided by 2, it means this becomes 55 degrees. And this also becomes 55 degrees. Then the next question is saying calculate the size of Q1. Calculate the size of Q1. If we check, here is our Q1 there. And we know O, M there you are told is the center. So it means QM is the radius. So we know that the angle PQM must be equal to 90 degrees. Why are we saying so? It's a tangent which is perpendicular. A tangent which is perpendicular to the radius. Then from there, PQM is made up of Q1 and Q2. So we are saying Q1 plus Q2 must be equal to 90 degrees. But from the previous question where we said R2 is equal to Q2, we established that Q2 also be equal to 55. So it means Q1 will be equal to 90 degrees minus the Q2, which is 55 degrees. So it will therefore mean that this Q1 will be equal to 35 degrees. Yes. Then the last question is saying how here. So we established that here is 35 degrees. Then from there, the last question is saying determine the size of M2. It's saying determine the size of M2. To get the size of M2, if we are to check, we go to triangle QMR. So in triangle QMR, we can establish that Q1, the angle Q1. So before we go to those angles, we can establish that MR is equal to MQ. The reason for that, they are both radii. Once we have that, so it means QMR, the angle, therefore Q1 will be equal to angle R1. The reason, these are angles opposite equal sides. Those are angles opposite equal sides. Then from there, we can now say R1 plus Q1 plus the angle M1 must be equal to 180 degrees. The reason these are sum of angles in a triangle, sum of angles in a triangle. So it means the M1 must be equal to 180 degrees minus Q1, which we know to be 35 degrees, minus R1, which we know is equal to Q1, which is 35 degrees. So we can conclude that M1 is equal to 110 degrees. But if we check, we are told that QR is equal to VS. And we know that equal chords subtend equal angles at the circumference as well as at the center. Therefore, we can conclude that M1 is equal to M2. What's the reason for that? It's equal chords subtend equal angles at the center. So we can conclude that, therefore, the M2 must also be equal to 110 degrees. Alternatively, you can do this after you calculate this triangle. You can prove that the two triangles, triangle QMR and triangle VSM, are congruent because this side and this side are given. This side is radius, this side is radius, and this side, so these sides are equal. So we can conclude by saying these two triangles are congruent. Therefore, this angle and this angle are equal, which is going to end up still giving us 110 degrees. Right. In question 11, in the diagram below, O is the center of the circle. O is the center of the circle. Then you are told that CDE is a tangent to the circle at D. Then you are told that DB bisects ABC. Take note, if you are bisecting, it means you are dividing into two equal parts. So it means DB, this line is dividing this angle ABC into two equal parts. Then they are saying let B1 be equal to X. So here is our B1. Let it be equal to X. Then the first part is saying prove that BC is parallel to OD. So in that particular case, here we can conclude that B1, that is for question 11.1, we can conclude that B1 is equal to B2. Why are we saying that which is equal to x? It's because we are told that DB bisects ABC. It's dividing it into two equal parts. The reason is DB bisects the angle ABC. Then we can conclude that OB is equal to OD. This part and this one are equal. These are angles, so they are both radii. You check there, both radii. Any line from the center, yes, the center to the circumference, from the center to the circumference is radii and they are equal. So we can now conclude that D1 is equal to B1, which is equal to X. Why? Those are angles opposite equal sides. So now since we have proven that this angle is X and this angle is also X, as we can see it has been proven there, we have alternate angles. We have alternate angles, so we can conclude that BC is parallel to OD. The reason, converse, alternate angles. Since these angles are alternating and they are equal, it means these two lines are parallel. Then they are saying show that C, it's 90 degrees. So since we have proven that these two, okay, show that it's 90 degrees. Okay, it's fine. It means we can conclude that angle CDO, that CDO is equal to 90 degrees. What's the reason for that? It's a tangent that is perpendicular to a radius. Since you are given that this line is a tangent and you are given that this one is a radius, since OD is radius, you are given center D is, so it's tangent perpendicular to radius. And we can now add the angle C there plus the angle CDO plus the angle CDO must be equal to 90 degrees. What's the reason for that? What's the reason for that? Because we are already given that, we have already proven that these two lines are parallel. This and see the reason, these are co-interior angles. Co-interior angles, which lines are parallel? You have proven that BC is parallel to OD. Can you please take note here? The angle is not supposed to be 90 degrees. It's actually supposed to be 180 degrees. For co-interior angles, it's supposed to be 180 degrees. So it means the angle C is equal to 180 degrees minus 90 for CDO there, which is going to give us 90 degrees. That was one way of doing it. Alternatively, you would first establish that CDO is 90 degrees. Yes, first establish that CDO is 90 degrees. The tangent is perpendicular to radius. Then when we now have that one, we calculate the angle D2. We know from that it's going to be D1 plus D2 is equal to 90 degrees. If we check, it's this one here, because this angle CDO is this angle D1 plus D2, but we know D1. So it means our D2 is equal to 90 degrees minus X. When you give this angle, we are saying this angle is 90 degrees minus X. So we consider triangle BCD. In triangle BCD, if you say D2, so after that, we are going to go specifically in triangle BCD. We were going to say B2 plus D2 plus C must be equal to 180 degrees. What will be the reason for that? What will be the reason for that? These are sum of angles. Sum of angles in a triangle. So it's going to be B2, which is X, plus D2, which is 90 degrees, minus X, plus the angle C must be equal to 180 degrees. So leaving the angle C alone, if we take simplifying this part, the C, the X here, and the X here, it was going to be eliminated. X minus X is 0. So it means the C will be equal to 180 degrees minus 90 degrees, which will give a 90 degrees. That was the alternative way of doing it. Then lastly, it could have been done it differently again. So it means one would come and say, no, let me start with this angle. And take that angle C, DO is 90 degrees. Then you go to triangle BOD. So in triangle BOD, we are going to have this angle D1 plus this angle B1, we know them, plus this angle, which is O2, must be equal to 180 degrees. Then, making O2 the subject of the formula, O2 will be equal to 180 degrees minus 2x. Here, why did we say this? The reason here is going to be sum of angles in a triangle. Then, when we now have this O2 to be 180 degrees minus 2x, we consider the quadrilateral BODC. We know that in that quadrilateral, adding all the four angles, so O2, which is 180 degrees. So here it's in quadrilateral BODC, 180 degrees minus 2x plus this whole angle here, which is x plus x. So it was going to be plus 2x, then plus this whole angle here, which is already proven that it's 90 degrees there, plus 90 degrees plus this angle here, which is our angle C, must be equal to 360 degrees. Then what could be the reason for that? It's sum of angles in a quadrilateral. Sum of angles in a quadrilateral. Then take note, this part minus 2x plus 2x, this part will cancel out. Then we now have your angle C being equated to 360 minus 360 degrees minus 180 degrees minus 90 degrees here, which is going to give a 90 degrees. Eventually, the answer here was going to be a 90. So it was going to be a 90 degrees for your C, which was the requirement of this question. Right, we are on now question number 12. We are given, on question number 12, we are given that in the diagram below, two circles touch each other externally at point P. Here, that's where they touch. The two circles, we've got this bigger circle and this smaller circle here. Then you are told that PQR, this is QPR. QPR is a common tangent to both circles at P. Then you are told that EDRC, that one, is a tangent to circle PBFC at C here. So this one is a tangent. Then you are told that RCA, this is RCA, you are told that is Y, and you are told that DAC, this DAC is also equal to X. Then you are told that AD, this AD, you are told that it's parallel to BC. Then let's go to the question. The first one is saying name with reasons 4 other angles equal to X. Want 4 other angles equal to X. So you are given here it's X. So if we concentrate on the bigger circle, if we check the angle here, A1, which is equal to X there, DAC. If you concentrate on the bigger circle, let me try to mark the bigger circle. If we are to just come to the bigger circle, this one, the bigger circle only. Yes. Let me try to erase here. If we go to the bigger circle here, okay, let me try to mark it. That's the bigger circle. This. If we only concentrate on the bigger circle, as we can see, we have this chord which subtends this angle X, and this chord is subtending that angle E. So we can conclude that angle A1 must be equal to angle E. Must be equal to angle E. If we are to check, let's mark that. If we check this angle A1, oh, sorry, that angle there, this one, is subtended, is, if you check that one, those two angles are subtended by the same. So the reason why those angles are equal, they're angles in same segment. In same segment. The angles in the same segment. So we can conclude that also angle E is equal to X. Then, if we are to check, still concentrating on that bigger circle, we are told that this line that line is a tangent. So there is a tangent and we have an angle between a tangent and a chord. Here is our chord. And we know the angle between a tangent and a chord must be equal to the angle subtended by that chord on the opposite side segment. So it means, using that, we can conclude that A1 must be equal to that angle P1. Must be equal to that angle P1. The reason is tan chord. Then we can therefore conclude that the angle P1 is equal to X. But if we are to check when we are there, instead of putting it that way, we can relate it to, because the angle between this tangent and this chord is also equal to. So instead of that, we can also relate it to say the angle E, which is there, must be equal to the angle P1. And the reason will be the same. It will still be tan chord. It will still be tan chord because the angle between a tangent and a chord must be equal to the angle. Then it concludes that P1 is equal to X. Then we are further given that AD is parallel. We are given that AD is parallel there. We are given that AD is parallel to that. So, since it's parallel, it means we are going to say that angle A1 will be equal to the angle C2. And what will be the reason for that? It's gonna be alternate angle. They are making a Z home. These are alternate angles. Which sides are parallel? We are having AD, which is parallel to CB. So we can therefore conclude that also C2 is equal to X. If we are to check, concentrating on the smaller circle, if we are to concentrate on the smaller circle, this one, concentrating on the smaller circle, there you are told it's a tangent there. So it will mean that this is a tangent, this is a chord in smaller circles. So here, taking this one to be the chord in a smaller circle, we can therefore conclude that the angle C2 is equal to the angle P is P5. The reason there is tan chord. So we can say P5 is equal to X. So we now have 1, 2, 3, 4. But take note on this angle. It was possible that if you check this line, DPB, it's a straight line. Then this line, it's a straight line. So it was possible that one would just say P1 is equal to, these are straight lines that are intersecting at P, is equal to P5. What's the reason for that? Those are vertically opposite angles. And whenever we have lines that are intersecting, we create vertical opposite angles. Therefore, it means the P5 is equal to X. So we have X here, we have X here, we have X here, we have X here, we have X here on this angle. Then the second part of the question, what is it saying? Then show that EPA is equal to X plus Y. This is E, this is P, this is A. So it's 12.2. If you check in this triangle EPC, if the side CP is produced, we now have an exterior angle here. We now have an exterior angle here. In other words, we are having this triangle here. Here is our triangle here. Here is our triangle, sorry. triangle here. Then this side becomes an exterior angle there. So when we produce that side, this becomes an exterior angle. So we can say P7, which is EPA, we can conclude that EPA must be equal to angle E plus the angle C1. Why? It's exterior angle of a triangle. Exterior angle of a triangle. So it therefore means that EPA must be equal to angle E, which is already proven that is X, plus angle C1 here, which we are already given, that is the angle RCA, which is already given is Y. Then determine the numerical value of, saying determine the numerical value of X plus Y. Determine the numerical value of X plus Y if it is given that D, C, T, P is a cyclic quantity. So we have to mark that. Let's go and mark saying D. Where is D? Here. D, C, T. So D, C, T, P. This one.